Yay! Okay. Thanks a lot, Bruce, for this wonderful introduction. I couldn't have done better myself. And thanks a lot, every person in the organization of JS Camp Romania for making this happen and for having me here. And thank you, everybody in the audience, for spending the next about 40 minutes with me to learn about machine learning for front-end devs, so for us. Just before I start, I thought I would introduce myself as like the real person that I am. So I'm a front-end developer. I'm French, but I actually live in Sydney, in Australia, so I came all the way from there. And as part of what I like to do as well is I'm a Google developer expert and a Mozilla tech speaker. So what these two things are, they're tech community groups sponsored by Google and Mozilla for people who like to share knowledge in different ways. So either speaking at conferences or writing blog posts or running workshops. They actually welcome people like me or maybe like you if you want to know a bit more afterwards. And you get to have some stuff, some exclusive stuff from Google or Mozilla, or you get to have them sponsor the way you share knowledge with the community. So if you have any question about that later, feel free to ask. But I'm not here to talk about myself. But one thing very important that I have to say is that I speak very fast. And first of all, because I'm really excited about what I'm talking about. So when I'm excited, I speak fast. It's kind of like word vomit, like blah, blah, blah. And another reason is because there's a lot of content in this presentation. Machine learning is a really big topic. And I wanted to make sure that I covered a lot of parts of what you can do in the front end. So I apologize in advance if I speak too fast. I could say I'm going to try not to, but I know I will. So I will share all the slides later, and I have a lot of blog posts around that. So if there are some things that you don't understand, feel free to ask a question afterwards or check the resources when I will share them on Twitter at devdevcharlie right after. So, what is machine learning? Some of you might have looked into it already, some of you might have not. So just to make sure that everybody is on the same level, I thought I would start with a very basic definition and example, just so that everybody can understand the rest of this presentation. So machine learning is giving the ability to computers to find patterns in data without being explicitly programmed. But that's the kind of definition that you can find if you just go on Wikipedia. And when I try to learn or teach stuff or share knowledge, I like to come up with examples that people can relate to. So the example that I took to explain a little bit what machine learning is recognizing spam emails. So we would all receive spam emails, and this is pseudocode, obviously, don't copy and paste that, this is not going to do anything. But you know, like when you think about all the emails that you receive, let's forget that machine learning is filtering them out for you. Think about what you would do if you had to do it yourself. So the thing that we know about spam emails is certain words that they contain, for example, Viagra. And you could kind of receive new emails and look if they contain the word Viagra and put that straight into the spam box. But the thing is, when people want to spam you, they get really creative with the way they write things. So you could have Viagra with spaces in between, with an exclamation mark, with a 4 instead of the A, and things like that. And as a dev, you don't want your role to be creating a spreadsheet of all the different ways to write the word Viagra so that then you can filter out your emails. I think what we want to do is more solving actual problems. And this is where machine learning comes into play, where using all the emails that you've received since you created your email address, you could actually create what we call a machine learning model that will recognize patterns in the way emails are written, or maybe where they come from, and things like that, to filter out emails automatically without you having to keep up to date a spreadsheet of words. So the way you would do that, you would use all the emails that you've ever received, use an algorithm to find patterns of what makes a spam email a spam one, and then using that model, every time you receive a new email it's never seen before, it will still be able to recognize a certain pattern in the email and filter it out, predict that it might or might not be a spam email. So in a very simple definition, this is what machine learning does, using a lot of data, finding patterns in it, and then helping you make predictions. And at the core of it, I talked about machine learning model, and to create a model, you need to talk about algorithms. So when I talk about algorithms, I'm not speaking about normal computer science algorithms like binary search and stuff like that. Machine learning has its own algorithms, and some of the ones that you might come across if you start looking into this is all these like fancy names, like naive Bayes, k-nearest neighbor, and things like that. And different algorithms are good for solving different types of problems. But before even trying to pick an algorithm to solve your problem, you have to understand what type of machine learning you want to use. And there's three main types that you will come across if you start looking into this. You have supervised learning, unsupervised learning, and reinforcement learning. For the purpose of this particular presentation, I'm only going to cover the two first ones, supervised and unsupervised. First of all, because I already have too much content, I can't cover as well reinforcement learning, but because most of the time, the things that you will want to build can be done with supervised and unsupervised. Don't even worry about reinforcement. Reinforcement is actually more if you want to do the whole self-driving car stuff. And maybe some of you are in that type of companies, but I think that in general, the problems that you'll want to solve will be with supervised and unsupervised. So if we talk about supervised learning, that's the creation of a predictive model based on a set of features and labels. And there's three core parts in the definition. There's the predictive model that we kind of talked about already, but we also talk about features and labels. So instead of just having this definition, I'm going to talk about an example as well that hopefully we can kind of all relate to, is predicting the price of a house. So we're in Bucharest. Let's say that we're lucky enough to own a house, but we want to sell it. And to sell it, we have to find a price to sell it for that it, which means that it can be bought quite quickly. You're not going to undersell and lose money and things like that. So you have your house, but you don't know how much to sell it for. What you have access to is data about all the houses in Bucharest. So in this case, the label would be how you would classify each entry in your data set. So that would be the price. In this particular problem, what you're trying to predict is the price at which you should sell your house. So that would be, when you look at all the data from all the houses in Bucharest, you would kind of have a column with all the prices of all the houses. And the features would be the characteristics of the entries in your data set. So for your house, or for all the houses in the market, you would know the number of rooms, the number of floors, does it have a garden, the number of windows. I mean, sometimes you don't know which features are going to actually impact your label. But using all this data of labels and features, you're going to use an algorithm that is going to try to find the correlation between the features of a house and its label, so its price. And using an algorithm and using all that data to find patterns, you will actually create a predictive model. And what that is the mathematical representation of the outcome of your training. So once the algorithm has looked at all this data and found patterns or correlations between them, you end up with a model that is a bit like a function that is ready to take new inputs, so new features from your house that it's never seen before, and then at the end predict a label of the price at which you should sell your house. So if you are in this kind of situation where you have a data set where you have labels and features and you want to detect something specific, you will look into supervised learning. And then inside supervised learning, you have different types of algorithms, but you can kind of like play around with it and find the one that works for you. But then I also mentioned unsupervised learning. And what this one is the ability to create predictions again, but based only on a set of features. And the end of that definition is really important because that's the main difference between the two. You don't have labels anymore, you only have features in your data set. So if we think about our example of predicting the price of a house, that wouldn't really work because if we know the number of rooms or floor or garden for all the houses in Bucharest, it doesn't really tell us how much you should sell it for if you've never known what a price was. Or if you don't know the price of all the other houses in Bucharest, you can't magically predict how much you should sell yours for. So unsupervised learning is more around clustering things together. So an example of that would be predicting customer behavior. If you go to the grocery store to do your shopping every week, they kind of know easily what you buy, when you buy it, where you buy it, like the time of day, or based on what you buy, based on the price of what you buy, they would know how much you earn and things like that. And in the end, using all of this data of all of their customers, you can cluster the types of customers together. So based on what I buy, I probably belong, they probably know that I'm a woman, they definitely know where I live in Sydney, they probably know approximately how much I earn, and based on that, they can put me in the same cluster as people similar to me, and based on what other people have bought, they would know what to advertise to me. So unfortunately, that would be used for advertising, but this is where instead of predicting something specific, like the price of something, they would try to figure out who I am and cluster me into the same group of people because the only thing that they have is my features, so what I buy, without really knowing who I am. So this is like the two different types of learning. So when you want to start doing machine learning, instead of just straight away diving into algorithms, try to think about the type of problem that you're trying to solve that will help you then figure out and kind of drill down into which algorithm you should choose. But now that I kind of talk broadly about what it does, I thought I would cover a few different applications of machine learning in JavaScript or in the front end. So I only picked 3, but they're kind of 3 different ones. I could do an entire presentations just with cool examples, but I don't have the time for that. So the first one that I'm going to show is actually the first one I came across when I looked into machine learning in JavaScript. So that's an experiment built by Sarah Drasner, where you would use machine learning to detect what's on a picture to generate the alt text for an image. So in this case, I think she's using one of the Azure Computer Vision API, where you can just submit an image, it analyzes what's in the picture, sends you a piece of text, and you can actually use that then in your code. So if you're thinking about, I don't know, a portfolio website or something, maybe it wouldn't be that useful, because if you only have a few images, you could do that yourself. But let's imagine that you have a website that has thousands of images. You can actually use machine learning to do the work that you might not want to focus on, to then go and fix problems that you want to spend your time on. So that's just like a prototype, but that's the first one that I came across, and I thought it was quite interesting. Another one that also was really clever is filtering unwanted content. So this one is a framework called Not Safe for Work JS. And I really related to this one, because before being a developer, I have a master's in marketing and advertising, so I worked for advertising agencies where when you work for some brands, they wanted to put together competitions where people could upload their own photos, and then you have like a winner, and they they win something. And you would have to, obviously, if you tell people only post selfies to win a prize, you actually don't know what people are going to submit. They could submit naked picture, and you would have to sometimes, if you upload them and the brand is like, oh, we want our website to be updated live with pictures from people, you have to make sure that the content that's on it is not naked pics. So the thing that you could use there, like this, it's just an experiment or a prototype as a framework. But actually, I could have actually used that to pre-filter the content uploaded by people instead of having to do it manually. Obviously, I don't think anybody wants to spend their time looking at thousands of pictures to just delete the ones that are not safe. So if you can use machine learning to do that for you and focus on other things, that's pretty cool. And then finally, the third example that is a bit different, but I thought was really, really good, is, again, it's just a prototype, but it's I'm going to butcher his name. It's Abhishek Singh. So he started thinking about the evolution of interactions with technology, and in particular, voice interactions. And he was thinking, well, if the future of interaction is using your voice, what about people who can't actually speak? Are we going to just totally forget about them? So what he did is he built this prototype using the camera feed, and he trained an algorithm to map certain gestures to sign language, so he could actually communicate with Alexa just by training an algorithm with images. And I thought that was pretty cool, because then you can really use machine learning to help people in some way. Obviously, this is just a prototype, but you can see that as JavaScript developers, we can build things like this already. So let's really dive into what you can do and how you can do it. But first of all, why does it matter? I know that in general, when you hear machine learning, the word machine learning, you think about Python, probably, because if you want to push something to production, you might actually focus on Python before everything else. But the fact that you can do it in JavaScript, the reason why I'm really excited about this is because it makes it more accessible. There's an easier learning curve when you, as a dev, you already know JavaScript. You already write JavaScript probably every day. So it means that all of a sudden, instead of learning a new language plus the concept of machine learning, you don't really have to learn a new language anymore. You don't have to spend time learning Python. You already know the syntax or how JavaScript works, and all you have to do is dive into a new framework, the same way that we kind of already do it when, I don't know, let's say you started a job and it was in Vue, and then all of a sudden everybody switches to React. It's kind of like the same thing. You learn the syntax of a new framework, which I think makes it a lot more accessible. The second reason why I think it's important is that it allows you to do rapid prototyping. And that's a lot of what I do on the side. Machine learning is not at all what I do on the job. All of this is what I do because I really want to look into this. And when you have an idea and you don't really know if you want to convince people to invest the time or money into the idea that you have, being able to use machine learning in JavaScript allows you to do rapid prototyping. You can spend a couple of hours or a couple of days just validating that your idea is possible, that you can do it. And then you might be able to actually go back to your boss and say, hey, look, like I built this. Obviously, it's not production ready, but it works. There is potential. And then you can have people actually invest the time and money into what you want to be able to do. And I feel like usually JavaScript allows me to do that a lot more than other languages. And finally, there is a bigger and bigger ecosystem of frameworks and tools and modules that you can use to do machine learning in JavaScript, a lot more than there was a year or two ago. So I think it's a great time to actually start looking into it. But what can you do? So there's three main features that you can do. You can import an existing pre-trained model, and what that means is that a model has been trained with a dataset already for a specific purpose, and you can just import it in your application and use it for that purpose. The second thing that you can do, which is my favorite, it's retraining an imported model that we call transfer learning. So it's a bit similar to the first feature, where you import a model that has been trained with a certain data set, but you get to add it your own and then retrain live and do some predictions. So it's a bit more personalized. And then finally, you can do the whole thing. You can define, train, and run models entirely in the browser. So that's quite powerful. I'm not saying that you should. I'll talk about it later, but it is possible. And in terms of tools that you have accessible, the one that you might have heard of the most is TensorFlow.js, backed by Google, but it's not the only one. I know that the first time that I looked into machine learning, I didn't start with TensorFlow.js because I found it a bit difficult to understand. On top of understanding the concepts of how machine learning works, you had to understand certain terms that TensorFlow makes you have to use, like, for example, what is a tensor kind of thing. And but if you start looking into this, you don't have to start with TensorFlow.js. There are other tools. I think ML5.js is pretty cool because it abstracts some of the concepts, so it makes it really easy for you to get started. Then you have more specified frameworks, like the M in the middle is for Magenta.js. That's a framework that allows you to do music-specific stuff in machine learning. So you can have machine learning algorithms generating pieces of music for you. And then finally, if you don't want to write any code, but you just want to play around with some APIs, you have tools from Microsoft, Amazon, and Google, where you can just ping an API, like they already have pre-trained model, and you don't have to do any code. If you want to do image recognition, you would just ping an API with an image that you already have, and you would get back an answer and things like that. So there are different ways to get started looking into this. OK, so now that I talked about what you can do and what tools you can do, that you can use, I thought I built 3 different demos to cover the 3 features. And I'm going to go through the code as well, so that hopefully you'll see that it doesn't take too much time to understand how it works. So my first demo is covering the first feature, using a pre-trained model. So for this one, I built, I didn't really know how to call it, so I called it, can I recycle that? So creative. So it's an app that, it's in the browser, so it can work on the desktop or on your phone, where I want to get better at recycling, but I always forget what goes in which bin, like the recycling one or different ones, and also by country, they're different. So anyway, so I wanted to be able to use machine learning to help me do that. So I'm going to demo it on my desktop, but originally it works on the phone. So what I wanted to do is if I walk around and I'm going to throw my bottle, I want to be able to scan it, and it would tell me which bin I should throw it in. But I'm not going to demo on my phone because it's it would be useless. So if I exit, oh no, or I'm going to have to reload because it didn't. Oh no, resolution is just resolution is not great. Let me just. Oh, that's not going to be, it's going to be a bit difficult. So, I have the camera, oh my god, never gets easier. So, I'm getting away from the camera because if I am here, it's not smart enough to know, I take more space on the camera feed than the bottle. So it's going to look at what it recognizes the most, and it's an image recognition model, so it's going to see that I take a lot of space and the bottle is too small. So I need to get out, and I need to put the bottle in front of the camera feed, and I have the is this recyclable? I need to show, no. Yes, OK, so it's a bottle, and then and at the end, I just click, where should I throw it, and it's going to tell me the yellow bin. I mean, in Australia, that's yellow. I don't know how it is here. But you can then go around and scan different objects. Obviously, this is a prototype. You could see that it wasn't working very well. But I'm just going to, so the machine learning part for this example is just the image recognition. The rest is just normal engineering, where you could ping an API with whatever was recognized, and it would tell you where to throw it. So if I put back present, is it the resolution? Yeah, OK, cool. So if we look at the code, in this example, we start by importing the model. I use the Coco SSD model. That's an image recognition model, and I import TensorFlow. You load the model to be able to use it. And then you're gonna use some of TensorFlow built-in methods to kind of like gather all the pixels from the camera feed. You kind of have to do some data processing to transfer the pixels into something that TensorFlow can understand, which would be tensors in a certain format. So I'm not going to go into exactly what all of these methods do. You can look at the documentation, is pretty good. But basically, you take the pixels from the camera, you transform it into a way that TensorFlow understands, and then you give that processed image to the model, and you return the predictions. So in about, I don't know, 10, 15 lines of code, you can use a pre-trained model and just have some predictions in the browser. So that's pretty cool. And it's like the first, like the really, let's say the easiest feature that you can do. So in my case, I use an object detection model, but you have different open source models that you can find on GitHub. So now the second one. That's my favorite. But so transfer learning. So as I said, you use a pre-trained model, but you add your own data samples to it. So for this, I started from a prototype called Teachable Machine by Google, but I just transformed it to do what I want. So in this particular case, I wanted to see if machine learning could help people with some kind of motion impairment be able to communicate anyway. So I like to try, every time I try to build something with a new technology, I'm trying to find ways that it could actually make some people's lives better. That's just a prototype though. But let's see. I'm going to close my thing. Yeah, that should be all right. So if I start the training, so the camera feed is going to, if it loads, yes, it's going to be small, but it's normal because I just put it there because I wanted to show you, like, me. But you actually don't need it. What I'm going to see, what I'm going to do, okay, it's a bit off, but okay, so there's my face. And I have 4 different directions. So I'm going to tilt my head to the right, and I'm recording samples of right, and I go left, and then I go down, and then I stay neutral. And before I start the predictions, I'm going to test them. So OK, and if I go down, it's down, and then left, and then right. And what happens then when I start the prediction, I have an interface of a keyboard where I can just select the letters and go right and left and just be able to write something. T, yeah. So obviously, I'm not writing something that makes sense here, but it means that in a few lines of code, in maybe a couple of days over a weekend, you actually, with your JavaScript skills, you get to actually build something that could help people. Obviously, this doesn't go to production. Definitely wasn't paid for this. But it means that I know that, to me, a few years, 7 years ago in my life, I know that if I had known that I could have done this, that would have changed something for one person in my life. And I think that's pretty cool that we have the power as JavaScript devs to actually build things like that instead of fighting about, is CSS a programming language? But anyway, so that's like a waste of time. But you can really, it's in the browser. Like it's just TensorFlow.js and you can just build something really cool. Anyway, so the code for this is just a little bit more, a few more lines. So instead of using the Coco SSD model, I used the MobileNet module just because I started off something that was already created, so I just reused the same thing that they used. You import TensorFlow.js again, but you have to add a third thing, that's a new classifier. So KNN is for k-nearest neighbor, that's a type of algorithm, and you need it because, as I said, you retrain live the model to understand your own samples, not only what it was trained with before. Then you start by declaring some variables. There's a number of classes. For me, it's 4 because I had right, left, down, and neutral, but it could be as many as you want. The image size, that's why it was small, because in this particular framework, they want the image size to be 227 pixels, because the more pixels you have, the longer it's going to take to train the algorithm. So you kind of want it to be quite fast. So that's kind of like a small size. The top k value is the k in the k-nearest neighbor. I'm not going to go into that. It's 10 in this particular example, but you see how accurate your prediction is. It can be different. And classes is the classes that you want. Then you instantiate everything. You create your classifier. You load your module. You do the same thing as before, where you take the pixels from the camera. There's a few, I'm actually not sure exactly how to explain what this method does, but what you want to do is, MobileNet was already trained with a certain amount of data, and what you're going to do, image from your webcam, you try and merge things together to retrain it. So you add all of these examples from the pre-trained model and the new data samples to the k-nearest neighbor, and you're going to launch the prediction. So now using the live feed from the camera, it's going to look at everything it was trained with, and it's going to give you back an index that you can match in your classes, array of classes, so right, left, and stuff like that. And once the retraining is done, you can dispose of the image from the webcam because you don't need it anymore. You have retrained the model. It's ready to go with your new samples. So there's a few more lines, but at the core of it, this is what you need to do. And, OK, finally, doing everything. I'm going to have water before I do this one, because, yeah. So this one was to define, train, and run your model in the browser, so everything in JavaScript. And for this one, what I built is a wheelie detector. And so I know, OK, so I thought at first that everybody knew what a wheelie was, but then I realized that, no, it's not a word that you usually Google. So a wheelie is a penis, but not pictures. I'm not talking about pictures. I don't want to see this, and I don't want to have it on the screen here neither. I'm talking about drawings. So the reason why I built this, before you'd be like, what the fuck? So the reason why I built this is because I wanted to build something else. I wanted to build an installation with like a matrix of LEDs, and I wanted to allow people to, using WebSockets, to draw something on their phone, and it would be projected live. And it could be like all over the world, as long as you just log in. I mean, you don't log in, you just visit a web page. You'd be able to draw something. I could draw in Australia and have my drawing in Berlin or something. But even if I tell people, please do not draw wheelies, well, I mean, obviously, you know how people are. So I was like, well, I don't want to spend 24/7 in front of my computer to make sure that there's no wheelies projected in a massive matrix of LEDs. So I was thinking, well, I'm sure machine learning can do that for me. Well, I mean, like, I built the thing. But yeah, so it works. So I'm just going to show it quickly. If I exit, I'm going to close this one. So is it? Oh, the canvas? OK. I like because the resolution on that screen makes the canvas quite big. Usually it's a bit small, which I prefer because I don't want a giant wheelie on the screen. But it's actually quite big. So for this particular example, I trained it with drawings of candles and drawings of wheelies. So I didn't train it with thousands and thousands of different stuff because I didn't have the time. So just to make it more accurate, I reduced the amount of samples. So if I draw a candle, I'm very good at drawing. So it tells me, OK, that's not a wheelie, so that's good. Then I clear it. And then if I do draw a wheelie, it should tell me, wheelie! And yeah, I know. I think this is the best thing I've ever made in my life. But what is really interesting is that I drew it a certain way there, but as it's machine learning and it just recognizes patterns in data, it doesn't have to be drawn a certain way. That's a weird one, but yay! See, I mean, like, that's the thing. It's like it just recognizes patterns. It doesn't have to be given exactly that picture. Very useful. But let me go back to the code. So instead of just talking about the code, I'm going to talk to you about the entire process of doing that by yourself, because if you can't find a pre-trained model to do what you want, you will have to gather the data yourself. So the first step is data collection. So on the right, you have the quick draw dataset. So that's a dataset by Google where they created this game online where they were giving you a counter, like you had 10 seconds to draw the word. So there was a draw, like, I don't know, like raspberry, and you had to draw a raspberry. And what they didn't tell you, or I don't know if they did tell you, is that they were downloading the pictures that you were drawing so that they would build this entire open source data set of hundreds of thousands of drawings. Obviously, they didn't ask people to draw wheelies, so I had to do it myself. I did not draw 100,000 wheelies because, I mean, yeah, no. So I drew a few hundred, which was already too much. I reached the amount that I just couldn't do this anymore. So I drew a lot of different shapes. But then the thing is, in the data set, it's 28 by 28 pixels, so to be able to actually use my drawings as well, I had to resize them, because my canvas was 200 by 200. To be able to identify patterns in data, the data has to be the same. So I just wrote a script to resize everything to the same size as the quick draw dataset. Then you have to split your set between the training set and the test set. So you use 80% of your entire data set to train the algorithm to create the predictive model, and you use 20% of that to test it against your predictions. So 20% is already labeled. You already know what is a candle and what is a wheelie, and you just test it against the prediction, because if you draw a candle and it says wheelie, you know that it's not right, and you can just retrain until you get a right accuracy. So then, once you split all your data, you can then pick your algorithm, because you know what you're trying to do, and you know the type of data you're dealing with. In this particular case, I used a convolutional neural network because I read that it worked well with images. For example, if you think about naive Bayes, the other algorithm, it doesn't really work with images. So I was like, OK, easy. I'm dealing with images, so I'm just going to go that way. And then you do parameter tuning. So you'll see in the code sample, there's a lot of different parameters that I actually don't always understand what they do, but you have to tune them a lot to get, and then you see if you get the right accuracy. So you train your model, you get the prediction, and based on the accuracy that you get, you might repeat these steps over and over until you get to something that predicts properly. So in terms of code, that's going to be a very short code sample over a few slides, because obviously, as I built everything from scratch, there is more code than just this. But as I said, so you have to create your training data and your test data. So you have to use some of TensorFlow built-in methods where you have to deal with tensors that I mentioned before. So obviously, when you draw something on a canvas, you deal with pixels. But so they could be numbers in a grayscale. But the thing is, to work with TensorFlow, you have to convert all your pixels into tensors. So that's what this does. It just creates tensors out of the data from your webcam. Then you create your model. So there's different ways of doing it. I'm not going to go into this neither, because it really depends on what you're trying to do. You add different layers. Here I have 6, but again, it's more of an art than a science at this point. You try different things and you see what works. So at the end, you return your model. Then you get your training data that you created before. You fit everything into your model with a few different parameters that you also, like the epochs is just the number of steps that you're going to take in your training. Mine was 3, but you could have 40, you can have 100. Like, it's really just up to you. Then you get your test data, because once you trained your model with your 80% of your training set, you use also the test set, and you're just going to compare these two, and you get the prediction. And if it's the right prediction, you know that you're done. You can use your model as it is. If the prediction is not right, you probably will have to retrain again. OK, so that was like, again, it's not really about understanding how the code works specifically in this example. It's more about understanding the steps, the splitting of the data, the creation of the model, and then the comparison between the example and the prediction. OK, so obviously I talked about what you can do, but I think it's quite important to talk about the limits as well. So you need a large amount of data unless you use a pre-trained model. So as I said, there's a few pre-trained models available on GitHub, but sometimes what you will want to do, there won't be any for it. So if you want to create your own, you will need a large amount of data, which is a bit of a limit. It kind of like, yeah, it could take quite a while. It can take a lot of time to train your own model, and that's why I was saying that you can, in JavaScript, define, train, and run everything in the browser, but you might actually not want to do it. The only way that I saw that it was actually useful is when people try to create visualizations of the training process. Then, if you train it in the browser, you're able to use that data to create some kind of visualization. But otherwise, I think it's quite limiting in terms of user experience. You don't want to train in the browser. You have to think about the mobile experience, because some models are actually quite heavy. The one for the recycling was, the object detection model was 15 megabytes, which is, well, huge. So when you load the page the first time, yeah, like you can wait quite a while. I preloaded it, that's why it was quite fast, but otherwise it's not great. So you have to think about that. Either you might find a model that's a bit smaller, or you build your user interface around it so users don't know that there's this loading in the background. Liability is an interesting one, where depending on what you're trying to do with machine learning, some models are black boxes in the way that it's basically, yeah, it's a mathematical representation of your training. So you won't actually understand how it happen to have a certain prediction. So if you want to build a machine learning model to accept loans for some people or stuff like that, if you get sued for a certain decision, you can't just turn around and say, well, I don't know, the model said that you're not, fit for this. Like, it doesn't really work like that. You have to be able to explain why a model made a certain prediction. So yes, be careful if you don't want to be sued or something. And then finally, and very interestingly, the topic of bias and ethics in AI is super interesting. Like, I really would recommend to read a few books and watch a few classes from MIT that I watched. I'll send the resources later, but it's really, really interesting. And what I would really like for people to understand is that algorithms are not biased. We are. A lot of the times, when you read articles or you just watch the news, people blame the algorithms. But it's just a piece of code. Like, algorithms, they can't predict something they've never really seen. I mean, they can predict something they've never seen before, but in a certain context. It just depends on the data it was given to create the model. So when you can't really say an algorithm is sexist or homophobic. It's the data that was given to it that was already biased, and the people creating this content is us. So I'm not trying to make you feel bad. Like, we all have bias, and to me, blaming the algorithm means that we are totally missing the opportunity to actually become better and realize our bias and being like, oh, well, damn, I didn't realize that I had this bias, and now I'm able to see it. It's like it's right in front of me because I created the data or something. One example of this is, well, that's small, but you can look at it later. It was Google Translate a few years ago that was translating like a gender-neutral language like Turkish into a gendered language like English. And all of a sudden, the word cook was feminine, so she's a cook, and engineer was masculine, he's an engineer, and hardworking was masculine as well, so he's hardworking, and lazy was feminine, so it was she is lazy. And the thing is, like, it's not Google Translate, like it's the data used for Google Translate was the data that we all create on Google, and that was already biased in the first place. So I think what is interesting, I think it's probably fixed by now, but what is interesting is that it can really make us face our own bias, and again, it's not to make you feel bad, it's kind of like, oh wow, maybe I didn't know that that's the way I thought, and now I get a chance to actually change it. And then what is really interesting is that when people actually get scared of machine learning, like it's going to kill us all kind of thing, you have a very interesting topic as well that's called the adversarial examples, where you can have an image of a panda, where at first if it's trained, if it tries to detect what this image is, it's 50% confident that it's a panda, but then you just add a bit of noise to that picture. So the pictures on the right is the result of the mix of the two, and all of a sudden it's 99% sure that it's a monkey. So I put the source if you want to read the article, but I really like this quote because, so basically it says, deep learning models are also brittle because an image recognition system relies only on pixel patterns rather than a deeper conceptual understanding of what it sees. It's easy to trick the system into seeing something else entirely just by disturbing the patterns in the right way. So when people figured out that you could easily trick machine learning algorithms, now you have companies also selling adversarial fashion, where you can wear certain clothes that trick computer vision systems, so that in societies where they actually track your face, you can actually look like you can trick an algorithm into thinking that you're actually not a person, so it's not going to do facial tracking. So that's interesting if you want to look into as well. But just before I finish, so that's not actually really, I mean, it's not a surprise anymore, but it used to be at the time. I've given this talk a few times, and at some point, I built something that was a bit different, that is a different talk, but I thought I would show you as well, because, so the inspiration for what I'm about to show in like the next 3 minutes is, so you can use machine learning in really, really a lot of different ways. All you need to have is data. So at some point, when I was doing some research and building prototypes, I came across this example where I'm not going to say his name because I butcher it all the time. So I just added the link. You can just imagine how you would mention his name. But on the right, yes, basically he trained an algorithm to look at data samples from a camera feed and then train it to recognize certain gestures and apply that to a game of Mortal Kombat. And I thought that was a really cool way to build like a personalized interface and quite a fun way to use the web. That wasn't actually, I don't think it was in JavaScript, I think it was in TensorFlow in Python. But when I saw this example, I was like, this is really cool. But the fact that you use the webcam means that you have to be in front of your laptop. So it's not great because it means as soon as you're out of the camera feed, you can't really play. And then also with computer vision, if the lighting, like at night, you can't play anymore because it just can't see you. So I decided to kind of like switch it around and build it entirely in JavaScript. And my version, I don't know if you see very well. Yeah, it's dark. But basically, so it's in the browser, but I projected it in my living room. This year, I've turned my living room into quite a few different things. But this one is a custom game of Street Fighter where I'm actually getting data from a piece of hardware that can interact with the browser. So I get data from my movements, I train an algorithm to recognize 3 different gestures, and all of it in JavaScript, I get to actually play a game of Street Fighter. So every time I tried to demo that, it failed. So I'm going to try again, hoping that this time it won't. But I don't really know. Well, I haven't done anything yet. All right. OK, so it needs Bluetooth. There's an error, but there's always an error. That's fine. So I'm just going to check that it didn't crash. It didn't crash yet. OK, we're good. We're good. OK. So if I do a punch, hopefully. No, and I knew it. OK, again. OK, I'll try 3 times. This terrible way to finish a talk. Come on, you can do this. We've done this before. So I know why it failed, but I haven't fixed it. So yeah. That wasn't the one I tried. let's pretend it did, okay? So, and I think the second, I'm going to do... Oh, yes! Woo, this one worked! Okay. So, thank you. Oh, it actually worked pretty okay. All right, so obviously I'm not going to have the time to go into this because I'm like a bit over time, but I did write a blog post about this, and all of it is in JavaScript, so I'm really excited about the fact that you can really build a lot of different stuff. Like, it can be games, and the data can be coming from anywhere. It could be the webcam, it can be pieces of text, it could be hardware data. It's really up to you. So on this, I want to thank you very much for spending the last 40 minutes with me. And if you have any question, I will be around, but I will be sharing all the slides. I have a separate deck with resources. And yeah, I'll share that on Twitter as soon as I can. But thank you.